All right, so guys, it says solve using any method. What methods do we have? Factoring is our first method that we would like to use, factoring. And what else we got? Complete the square, and we also have the quadratic formula. Thank you. All right, now, guys, what form must you be in order to factor? You need to be in standard form in all of these. You need complete the square. That one needs to be in what? Vertex form. What about quadratic formula? It needs to be in standard form. Okay? Now, guys, in this case here, if I'm looking at number 1, Ronnie, what would you use? She completed the square on number 1. Ari, what would you do? She might just go ahead and try the quadratic formula. Why? Because she's not confident in the other one, maybe. I don't know. I don't know. People do this, and I'm not saying just you. I'm just saying I have a lot of students who just do quadratic formula on all of them. They try. And what will happen with this one, I'm just going to show you. A is what? 1, and B is 9. You don't have to write this down. And C is negative 40. So I have students who start working on this. Your quadratic formula, you know it by heart? That's what it said. All right, so.
No, you said A is 1.
I said you're A1 in my book, is what I said. All right, so what is the quadratic formula? There you go. Guys, that is half the battle. I have students who don't know that. You need to know that. You're going to have to know it for this test. Now, guys, when I put in negative 9 over 18, that is an indicator that my numbers are too large. Now, plus or minus the square root of 81 minus 4 times 9 times negative 40. Who in the world would want to multiply that together? So, I have students who get here on the test and the numbers are too large to go ahead and try it anyway, and it will be a miserable fail. Okay? Now, this, guys, this right here, when you get done with that, this whole thing ends up being a perfect square. If that is a perfect square, it means it would have factored. Okay? Which is crazy, but this will factor. Now, so I was telling them in the last period that if they ended up doing a quadratic formula, you end up with a perfect square and the numbers are too large for you to manipulate, go back and factor it. So, what are your factors there, Mr. Moore? You said you're going to factor it. What'd you get? That's what Camden did. I saw that on his paper just a minute ago. He went ahead and factored that. Guys, look how fast and easy that is versus trying to do the quadratic formula. Okay? All we did was take 40 and go, 1 times 40 and got all the way down to 5 times 8. Use the 5 and the 8 and the 3 and 3, and it came out. Okay? Guys, when you're taking the test, there will be a section that has like 4 or 5 solving problems. One of each is going to show, I want you to do quadratic formula on this one. I want you to factor this one. I want you to complete the square on this one. And the other ones, you can choose whatever you want. But I will tell you, they are pointed in the right direction. When your numbers are large, probably a good indicator is probably going to factor. Okay? If my numbers over here, look at number 3. 2x plus 1, right? Well, I got to move the 7 over. Would that be a good one to factor? No, it doesn't factor. So do you complete the square on that one? He said yes. You want to complete the square on that one? Why not? Yeah, that would be x squared minus 7 over 2. And then you got, I got to take half of 7 halves? Wow. Now, Corday can probably do fractions. He can probably handle it. It's fine. Sure. But what method should you use, Riley, on this one? Yeah. Look at the numbers. Guys, A is 2. I'll make sure the numbers are right this time, Ronnie. B is negative 7. And C is equal to 1. Okay? Is C 1 there, Ronnie? I just want to make sure. Okay. Now, these numbers have been verified by Ronnie, so we're good. All right? In standard form, it's, your standard form is ax squared plus bx plus c. So you need to have it in standard form in order to get your a, b, and c. So this morning, I had a kid in tutoring this morning when a is 2, b is 1, and c is negative 7 or positive 7. That's wrong, right? He used these numbers instead. He made that a 7 instead of negative 7. And so he put A, B, and C, and he's going to get it wrong. We are going to test you on that. Guys, we're going to make sure it's not in standard form. You got to put it in standard form and set it equal to 0 first, okay? So once we have it there, guys, it's negative B, which is 7 over 2 times 2, which is 4, plus or minus the square root of 49 minus 4 times 2 times 1, all over 4. Now, Jace, I will tell you, in this case here, I seem to always circle this. All right, so let me explain why I circled that, Jace, all right? You guys are horrible at order of operations, that's why, okay? So, if I put a string of numbers together, there are, I go 49 minus 4 times 2 times 1. I will get all sorts of weird answers. Because I'll have people who will multiply those together, or they'll subtract those, make that 45 times 2, and they get 90 underneath. Order of operations says you must multiply before you add and subtract. Now, if there's a negative in here, it really messes them up. Because then they start subtracting instead of multiplying by a negative 1. So, in this case here, I want you to, what's circled is all multiplication, all of its multiplication, so it ends up being a minus, 8? So I have 49 minus 8, which is, Grandpa Rapper, 41 is right. 41. There it is. If you haven't seen him yet, you gotta look him up. He's kind of fun to watch. Yeah, that's where it comes from. I put you on. Yeah. You understand? That one definitely is looking to be, I got it. That one is definitely looking to be quadratic formula. The quadratic formula is nice if A and C are fairly small. Okay? So in number 1, 9 and 40 are not small. That will jack the number up. Does that make sense? All right, so take a look at number 2. Now Camden screams, that one's screaming, hey, complete the square. Okay, so Camden's completing the square on this one. So he subtracted the 1/2. He went ahead and set up the 2x squared plus 8x plus blank minus 1/2 minus blank. I'm going to go ahead and do this one by completing a square. However, I will show you another method that is not that bad, okay? Quadratic formula, using quadratic formula in this would be fairly easy, okay? But on the test, Ronnie, Friday, guess what you have to do? And solve. So you've got to complete the square and solve. So it's got to go from all the way into vertex form back to the x equals. Do what? Yeah, you'll have a piecewise in this, correct. So, first thing we're going to do, set up your parentheses. Take the 2 out, right? Put the 2 in. Remember, if you take the 2 out over here, you must put it over here. Set up your two PSTs right here. What number goes there? Dos is correct. Multiply them together gives you what in the blank? 4. So 2x plus 2 squared minus 1/2 minus 8. This is all equal to 0 all the way down through here. Don't forget to equal 0. Guys, if you take each of these and you set them equal to 0, this first one's already set, so you don't get any points. But on this one over here, if you set this one 2x squared minus 7x plus 1, you set equal to 0, there's a point for doing that, Jay. So you say, I can't solve it all. At least do that. And then you do part of the quadratic formula. Plug in your A, B, and C. Even if you can't finish it, plugging it into your quadratic formula will give you some points if it says use any method. Okay? At least find your A, B, and C, plug them in. Don't give up. Get partial points as much as you can. Don't sit there, I don't know nothing. Make an educated guess. Please do not put rust bucket and chains on there or something. Okay? Those are uneducated guesses. Well, my answer here is rust bucket. Maybe up in automotive. All right, now. So, what's going on here? What do we got to do with this? Common denominator of 2, so that makes that a 16. So that gives a total of what? 17, that's right. Evan Daly, his 17th birthday was yesterday. All right, now. Yeah, and the boys won last night, so he got a birthday present. All right. What's next? All right, so we have it in vertex form, Riley, right? So we get it to vertex form. We know our transformations, but we can't graph it. We're not going to be able to find the solutions because they are going to be irrational. So in this case here, we have to solve it. So how do you solve a vertex form? Yeah, add the 17 over 2. Make it positive 17 over 2. Multiply by the multiplicative inverse. So that 2 goes away, and I'm going to isolate the x plus 2 squared. So your whole idea here is to get that by itself. This ends up being 17 over 4. Now, this is where the pain in the butt comes from, right? The piecewise is coming up here. It's not too bad. I think it's a pain because I have to write it. It's not hard. It's just like, ah. All right, so absolute value of x plus 2 here. 17 over 2 right here. That's nice. I'm going to piecewise. Do you guys need to be right to piecewise? Okay, I'll write it for you. F of x equals x plus 2, x plus 2, x plus 2 greater than or equal to 0, x plus 2 less than 0. Write two equations. X plus 2 equals the square root of 17 over 2, and negative x plus 2 equals the square root of 17 over 2. No, it was over 4, but when we took the square root right here, it's now 2. Subtract 2 from both sides. So my two solutions end up being x is equal to negative 2 plus and minus the square root of 17 over 2. If you want to write it like that, you can. You can keep them separated, Ronnie, if you wanted to. I don't really care. I've been keeping them separated, if that makes sense. because it ends up being minus 2 plus the square root of 17 over 2, and then I need to move the negative over there. And so I get the same exact answer, but it's conjugate. If you want to write them as one piece, you can. Okay? You good with that? Now, as I said earlier, this one would probably have been easier using the what formula? Yeah. Now, you need to know that A is 2 and B is 8, and I got to move that half over, so C is equal to negative 1/2. Now, pay attention to this. This is being really sweet. X is equal to negative 8 all over 4 plus or minus the square root of 64 minus 4 times 2 times negative 1/2. Okay, and then write that all over 4. You with me? Now, take a look at this right here. We're gonna multiply that out. What is negative 4 times 2 times the negative 1/2? Positive 4. That's correct. So, this reduces down to just a negative 2. 68 over 4. Can't leave it like that. This is my answer right here. We're pretty close to it, though. We just got to fix the 68. What times what gives you 68? It's even. Can you cut it in half? 2 times 34, right? What else? 2 times 2 times 17. So pair of 2. So I get 2 square root 17 over 4, which then that will reduce to that over there. Okay? So I think quadratic formula was doable in this one. Okay? Why? Because look at my A and look at my C. My A and my C were fairly small. Does that make sense? Okay? So if it says any method, you can use any method, all right? If I ask you to solve it by complete the square, or if I ask you to solve it by factoring, you've got to use those techniques, okay? All right, let's take a look at the second part, 4, 5, and 6. When you see discriminant, what do you think of? I think a quadratic formula. What part of the quadratic formula is it? It's the what? Nope, it is the other part. It's the b squared minus 4ac. You're thinking x equals negative b over 2a is that's your axis symmetry. That was what you were thinking. Okay? Which we need to know. That's the axis symmetry. The other part is the distance from it. But the b squared minus 4ac tells us either we're positive, we're negative, or we're 0. Right? Remember, if it's 0, what do we have? What happens to your square root when it's 0? When I have x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Jace, if this square root is gone, then that plus or minus is gone, isn't it? So that means I only have how many intercepts? One intercept. It happens to be a double, right? It bounces on that. So in this case here, it gives me one double solution. You probably need to write this down somewhere. Again, the more times you have it written down there, Ari, the more times you remember. So if b squared minus 4ac is equal to 0, it's what? One double solution. Write it down. Good. All right. So, what's your other option? Sure. What's your other option? B squared minus 4AC is less than 0. 2 imaginary solutions. B squared minus 4AC is greater than 0. 2 real solutions. But under that, you have to say what? You've got rational. Whoa. You have rational, right? And you have irrational. What is special about rational solutions? It has to be a perfect square. Okay? Now, there is I have an issue with this question right here, Ronnie. How many solutions do all of these have? So that's a wrong question. So what should we ask? How many x-intercepts do we have? That would be a better question. This right here is telling me how many intercepts we have. We have 1 intercept, we have 2 imaginary intercepts, or we have 2 real intercepts. That's what it comes down to. The other one says how many types of solutions. It'd be like, all right, we got rational solutions or irrational solutions or imaginary solutions. All right? So that in this case would say the state's going to ask you how many solutions, Ronnie. You're going to say 1 or 2, which is really the wrong thing to say. That's the wrong question to ask, but they'll probably ask that question. So it's either 1 or 2 solutions, right? They might even say none. If imaginary, they might go, oh, there's none. There's 2 solutions on all of them. All right, now, so in this case here, when it asks for the discriminant, we're looking for the number. I think the state just gives you the number, but we're going to go ahead and calculate it. So A is 2, B is 3. I'm still stuck on A being 1. And C is 1. Here, so we do the math on this. We get what? 9 minus 4 times 2 times 1. What do you get? Remember, when you're doing this, you always multiply all of that first. What is that? -8. So I get 1. So my discriminant is positive 1. How many solutions would that be? 2 real solutions. What type of them? What are we going to call them? Rational. Why do we know the rational? Because that's a what? Perfect square. That's why. If it was a 5, nope, that'd be irrational. Okay? It's 1, 4, 16, 25, 9. All those numbers are perfect squares. That would be rational. Any other number other than the perfect square is irrational. All right, what about number 5? What if that happens on your test, Ari? Start crying? Yeah, I'll be doing so too. We'll get Riley in here so she can see this. Because this looks difficult, doesn't it, Miss King? What's your A in this one? Okay, so now you see that right there? You see that symbol? That's a 0, which means that if we multiply one side of the equation by one side, by any number, we can have to multiply the other side. And what happens when you multiply it to 0? 0. So could we just multiply by the common denominator on all of these? Yeah, that would give me what? 50x squared, correct? Minus 5x, correct? Plus 2 equals 0. Questions? So, discriminant would be what? Square your b, which is squaring that. 25 minus 4 times 50 times 2. 4AC. Remember, we're doing b squared minus 4AC. What do you notice about 4 times 50? What's that? 4, all right, 2 times 50 times 4. 2 times 50 was 100, and 100 times 4 was 400. 400 minus 25. You got negative what? 375. So how many intercepts are there? 2 imaginary. All right. So we actually have 2 imaginary solutions because that is negative. All right. Last but not least over here, before we get to the calculator problems. I'm trying to go over everything, Santiago. I know you know it. I know it's kind of like we're dragging. You know, this is getting kind of. I mean, some of you guys who are super talented, this is kind of real slow for you. All right, I understand, but it's the same way with my swimmers. I have swimmers who are like over in lane 5. They're like whipping out great times, and these other kids are like slow poking. It seems like, but they're getting better. Everybody's getting better. So everybody's getting better. All right. So this one here. Anybody get it yet? So A is 18, right? B is negative 12, and C is positive 2. You see that, Riley? We have that equal sign. We're going to test you. We're definitely going to test you on making sure you're in standard form. Okay? It will happen either in the discriminant part or in your solving part. It's going to happen. Okay? I just want you to make sure you don't make that mistake. All right, so let's go through this. 144 minus 4 times 18 times 2. Backfire. I don't even know what 4 times 18 is. I bet if you multiply that all together, I bet you get 144. We're getting 0. How many x-intercepts do you have? 1. 1 double solution. Now, remember, it is also a real solution. So, 1 double real solution. You guys good? Does anybody have any questions on that? Ooh, I like it. So, she noticed in this case here, if you add 2 and you are equal to 0. Now, so over here, Ronnie says, hey, we multiplied everything by 25 and get it all larger. We could divide everything over here to make it smaller. So she asked, can I remove my GCF to make the number smaller, and would it still work? And yes, it would. It's a good observation. All right. So you can change that anytime. All right. Anytime you want to. All right. Multiplying. If you are in equals, then you can, yes, jack it up or shrink it. Okay. Enough on that. We went over quadratic formula. Quadratic formula. You see that one right there, guys? How many times have we had fractions when we're doing our quadratic formula? A lot. So you think it's going to happen? You know how to get rid of them? Multiply by the what? The common denominator. You can still do that. If I'm trying to find my x-intercepts, you are setting that equal to 0, so you're allowed to get rid of those fractions. Okay? So that would give me 3x squared minus 4x minus 8. And so I can use 3, 4, and 8. It makes it a lot better than fractions in that quadratic formula. Okay? You can always, when you use a quadratic formula, you can always take it and multiply by your common denominator and get rid of your fractions. Okay? You never have to work with your fractions in your quadratic formula. Right? Because your quadratic formula is a solve. That is solving. Does it make sense? So you can get rid of your fractions anytime you want to. All right, so we're going to go to 414, number 15. Oh, we got number 14 first. You remember doing this one yesterday? It's our third day in a row. You should not miss this one on the test. Don't make this one harder than it really is. So Ari, it says, I want to create a garden. With the borders outside, it says enough flowers to make 700 feet. It says I want to make it should say rectangular garden. So it's going to look like this. You ready, Ari? This is what it's going to look like. I think it's this pin right here. There you go. Okay, it's going to look like that. It's going to be bordered, a rectangle with flowers around it, okay? You don't have to draw the flowers on your picture. Just draw a rectangle, okay? Why doesn't it show up on you? There it goes. That's a rectangle. It looked more like a boat just a second ago. That was weird. All right, now, going back to my pen over here, let's put our links up there. How many links do you have? Yeah, one right there. A W right there and a W right there. And what are the two formulas you're going to use in your... You're definitely going to have to use A is equal to L times W. That is the definite 100%, does not change. The other one, since we're dealing with a border and we're talking about fencing, we're talking about perimeter. Now, your perimeter will change based on what's happening. Yesterday we had a river. The day before we had a house. The other one we had pins. So if I had 2 pins or 2 gardens, then you would change your L's, the number of L's and number of W you have. This case here, it ends up being 2L plus 2W. You got it, Dexter? So what would be the next part? Instead of P, you would put what? 700. Your border or your fencing or whatever we're using as a border is going to be your perimeter. Then you must solve for W or L. King, which one do you want to solve for, L or W? L. All right, so that means we would subtract the 2W from both sides and get 700 minus 2W is equal to 2L. How else do we solve it? Yeah, I got to get rid of the what? The 2 on each of these. So L is equal to 350 minus W. See that, Autumn? Now, you could have solved for W. You would have moved the L over and divided by 2 and got W is equal to 350 minus L. It would have been the same equation, just changing the letters. Now, this right here is going to be changed. We're not going to write L anymore up here. You're going to sub it in. Substitution in. All right. So I'm going to get A, and the letter we're looking for is W. So A sub W. And I'm going to put 350 there, Vincent, and put minus W and put a W. Now I got a quadratic. Because I have W squared. I can't use L and W. I got to have either LL or WW. Okay? Now, guys, if I'm looking at this as an equation that we've been working with, W turns into what letter? W is what letter? I write it like this so you can see that's supposed to be a what? An X. 350 minus X times X. And up here I have Y, or F, I should say. F of X. All right. So I get to use my handy dandy what? Calculator. So we'll pull it up. I'm going to do second plus 712. Reset my calculator so it starts from scratch. All right, can you borrow one? There's one back there. Right next to R2D2 back there. That was my best impersonation. Master's calculator, that is. I know. I'm not very good with Yoda. It's all right.
He's fine.
Yeah, more like a Kermit, like Mr. Moore. I'm Mr. Moore. How's it going? You know Mr. Moore? Not you. The AD at John Sevier. You ever met Mr.? Yeah, he's real tall. He's like talking like this all the time. He sounds like Kermit the Frog in the back. And he's got this Kermit the Frog kind of sound. If you know him, you would know it. All right. I can make fun of him because we went to school together years ago. So we started. We were finishing up our masters at UT together. So he started teaching here maybe a year before me. So he's got 30 years in it, at least, I think. I was at Boone for a year. So. All right. Oh, and William Blunt. Sorry, he may actually have a couple more years. He may be 32 years in. Because I started off, when I graduated from college, I bought a swim pool company. So I clean and service swim pools for a living. I travel all over Knoxville, cleaning and servicing swim pools for the wealthy, the one percenters who could afford pools on really nice vistas overlooking grand places who can pay for a pool boy. Guess who decided not to take that anymore because I couldn't take that from the arrogance of some of the people, honestly. So I was out of there in a heartbeat. I said I'd rather teach the young, educated, and educate you guys because I enjoyed being in the classroom and found my passion years ago. So heck, fire. Change the world by one student at a time. If I can change your life, the next thing you know, you're going to change somebody else's life. And it's going to butterfly. Next thing you know, we're going to have the world's going to be in the perfect spot because I got Vincent in the right spot. All right, now, there you go. You never know. It's a butterfly effect. This is crazy. All right, so type it in. Parentheses, 350. Whoa, what's that? Try this again. 350 minus x times x. I hit graph, and what happened? I got a straight line. Now, so let me show you the trick that shook the world this morning. Nora was in here. I showed her how to do this. So we went to our window, and we knew our fencing was not going to be more than what? 700 feet in width. So we went ahead and picked the 700 to be the longest it can be or the widest it can be. That's if it was completely stretched out. You took your flowers in a straight line. You can't, so you know it's going to be less than that, okay? Now, the next thing we did was we went to our window and we had to pick our Y. Now, our Y, in this case here, we just chose 1,000 to start with. We didn't know if it was going to work or not, but obviously it doesn't work. So we went back to the window and we picked it. Instead of doing 2,000, we just chose to add a what? Another 0. So we made that 10,000. We hit graph. I still don't see it. So go back to your window, go down here to 0, and pick it to be one more 0, make it 100,000. Hit graph. Bam. There it showed up. Now, if you wanted to shrink it, if you thought 100,000 too much and you want to go to 50,000, you could. It would just change the window setting. It would change it. You just go in there and change it. You can still calculate your maximum from here. So second, calculate number 4, arrow to the left. Maximum. Hit enter. Go to the right side. Hit enter. Bam, there it is. 175 equals 30,625. So write that on your paper. And then interpret that. The X is what? The X was your width. This is your max area. Now, your max area is always dealing with what? Feet squared. So 30,625 feet squared. Because you got to multiply your length times your width. Now, we said our width was 175 right there, and that's 175 right there. Feet. Don't forget your units. What would your length be? Well, it'd be 175 plus 175, which is 350, minus 700, which would be 350 divided by 2. We're back to what? So what do we have here, guys? A square. To maximize the area of something that has no boundaries, that has no, like, it's just locked in, you're just doing 4 sides, it will always be a square. Okay? So this ends up being 4s. Now, in this case here, we will not do that to you. You will not see this problem on the test. On the test, you will have something that will be either on the side, or you have 2 pins. You may have 3 pins. So in that case here, it's going to change. Does it make sense? A square was too simple. We got away from that. We used to do like 6, well, that used to be squares, and then they're like, oh, it's going to be a square on the test. And they just went, oh, just take that number and divide it by 4, I'm good. No, we're not going to do that, okay? It will not be that easy. All right? But make sure you do that. Questions? All right. Number 15, you good with that one? You got to put it in, and it says here you need to find what's the time it takes for it to reach the highest point. How high will it go? You should be able to answer that question maximum, right? Remember all the other questions. Take your test and look at your calculator portion and make sure you know what contextual domain means, contextual range means. Make sure you can find your x-intercepts, a time that's just relevant, like if I wanted to find a time out there in the middle of nowhere, or if I give you a certain height, it'd be find the 2 times it's that. So for instance, this one right here, let's say we wanted to know what happened when it was at 15 feet for this one. Well, that would be y equals 15 here, guys. So when you're using your calculator on this one, you've got to punch this in, and you're going to get 15. If you want to check to see if you can get it right, there are 2 answers. One answer is 0.459, and the other one is 2.291. I know, but they did. I don't remember. We did this last period, so I don't remember the actual other number. So you would punch this number in right here. I'll go ahead and do this one so you can see it. It'd be 40x minus 16x squared. When I graph this, I can't see it. It's way over here in this corner. You can't see it. So I'm going to zoom number 6, which will put me back into a 10 by 10 grid. Then I will change my window setting to make that maybe 100 right here, because I don't know how high it's going to go. Oh. There it is. Put y equals 15 right here. You see the 2 points of intersection is what you're doing. Second, calculate number 5. Hit enter, enter, enter. There's a 0.459. Second, calculate intersect. Just make sure you're on the other side near that other one. Enter, enter, enter. Missed it. 0.041. There you go. Questions? You may have any questions over the homework. The rest of the time is yours.